How do you react when NASA says the edge of our solar system may not be a clean wall at all, but something more like a torn, shifting seam? Because right now, a machine built before the internet, before smartphones, and before most of us were born, is sending back clues that the border around our cosmic home is far stranger than we imagined. If you love space stories that stay in your head long after the video ends, hit like, subscribe, and share this with one person who still looks up at the night sky and asks impossible questions. Out in the dark, Voyager 1 is still moving, still working, still talking. That alone sounds unreal. It launched in 1977 with a simple mission: visit Jupiter, visit Saturn, collect data, and send it home. Nobody expected it to become the oldest deep space explorer in history. Nobody expected it to outlive entire generations of technology. And nobody expected that nearly 50 years later, it would be the only machine directly sampling the space between the stars. That is where the story becomes bigger than the headline. When people hear the phrase, "a crack in the solar system," they imagine a giant hole as if space itself has split open. That is not what NASA confirmed. The real idea is more scientific and, honestly, more amazing. Voyager 1 has shown us that the edge of our solar system is not a neat shell with a clean border. It behaves more like a stressed, uneven boundary, a moving seam, a region shaped by pressure, magnetism, charged particles, and outside forces pushing back. Not a perfect bubble, not a smooth wall, something messier, something active. To understand why that matters, we need to understand where Voyager 1 actually is. Our sun does not just light the solar system. It also sends out a constant stream of charged particles called the solar wind. That wind rushes outward in every direction and creates a giant magnetic bubble around the sun and planets. That bubble is called the heliosphere. For a long time, every spacecraft humanity ever built stayed inside it. Even probes beyond Pluto were still traveling inside the sun's protective influence. Then, in August 2012, Voyager 1 crossed the heliopause, the outer boundary, where the sun's wind stops dominating and interstellar space begins. That moment mattered because Voyager 1 became the first human-made object to leave the heliosphere and enter the local interstellar medium. In plain English, it moved out of our sun's protective bubble and into the material that fills the space between stars. That sounds clean and simple. Inside the bubble, outside the bubble. But reality was not simple. Scientists expected that once Voyager crossed out, the magnetic field direction around it might shift sharply. But the data did not behave that way. The particle environment changed dramatically. The density outside was far higher than inside, which was one huge clue that Voyager really had crossed into interstellar space. But the magnetic field did not flip in the clean way many people expected. That created a mystery. Had Voyager fully left the heliosphere? Was it still in some strange transition zone? Was the boundary more twisted than our model said? Later analysis pointed to something important. The magnetic field near Voyager seems to have been slowly turning, as if the boundary region was still affecting the space around it. That means the border of our solar system is not like stepping across a painted line. It is more like moving through a distorted region where the sun's influence and the galaxy's influence meet, bend, and pull on each other. That is the first reason people reach for words like crack, even if the better word is seam. And then Voyager heard something. Not sound the way we hear sound in air. No one is claiming there are voices floating through empty space. But space is not truly empty. Even the darkness between stars contains thin gas, plasma, and magnetic activity. Voyager 1 carries an instrument called the plasma wave subsystem. It can detect oscillations in plasma, especially the motion of electrons in that incredibly thin interstellar material. Scientists can convert those measured frequencies into audio, which lets us hear patterns that would otherwise stay invisible. At first, Voyager mainly picked up brief plasma events linked to disturbances from the sun. Those events were valuable, but they were rare. Good for snapshots, bad for a full map. Then researchers looked back through the data and found something more subtle. Starting in the years after Voyager moved into interstellar space, the spacecraft was detecting a faint, steady, narrow signal. Not a burst, not a one-time spike. A hum, a real persistent hum. That hum mattered because it gave scientists a way to track electron density in interstellar space more continuously. Instead of waiting for a solar outburst to create a measurable event, they could use this constant background tone as a live reading of the medium Voyager was passing through. Suddenly, interstellar space stopped looking like a silent blank. It started looking like an environment with texture. And that is where the headline turns from catchy to meaningful, because the space beyond our solar system was often imagined as smooth emptiness. Black, still, dead, almost featureless. But Voyager's readings say no. The local interstellar medium has structure. It has variation. It has density changes. It has ripples and turbulence. It has regions that look slightly different from one another. even across distances as large as the space between Earth and the Sun. A place we used to call empty turns out to have weather-like behavior on scales so large they make our planet feel microscopic. So when people say Voyager found a crack, what they really mean is this: the boundary around our solar system is not sealed and simple. It is shaped by interaction. It is rough, layered, and dynamic. The sun pushes outward. Interstellar matter pushes inward. Magnetic fields bend. Plasma densities rise and fall. The edge is not a wall. It is a negotiation. And Voyager 1 is the only witness we have from inside that negotiation. Voyager 1 is now so far away that even a radio signal moving at the speed of light needs nearly a full day to travel one way. NASA says that in November 2026, Voyager 1 will become the first human-made object ever to sit one full light day from Earth. Think about that. If engineers send a message to the spacecraft, they wait almost an entire day just for it to arrive. Then they wait nearly another day to hear whether the command worked. A simple exchange can stretch across 2 mornings. There is no joystick, no instant correction. Every choice is slow, careful, and full of risk. Its memory is tiny compared with even the cheapest phone. Its power comes from radioisotope generators that have been slowly fading for decades. Every year it loses more of the electricity it needs to stay alive. Over time, NASA has had to turn off instrument after instrument because every watt matters now. By 2026, after another power-saving shutdown, Voyager 1 was left with 2 key science tools still working: the plasma wave instrument and the magnetometer. Those are the very instruments telling us this story. Quick pause before we go deeper. If this story is already changing the way you think about space, subscribe now, leave a like, and share the video with someone who loves the big questions. Because the next part is where Voyager's data gets even stranger. Now let's talk about the clue that makes the crack idea feel less like clickbait and more like a real scientific metaphor. Once scientists started using Voyager's plasma wave data to track density more continuously, they saw that interstellar space was not holding steady. The electron density around the spacecraft rose sharply after it crossed the heliopause, reaching levels far above what it had measured inside the sun's bubble. That made sense. Outside space was denser than the region just inside. But the story did not stop there. The density did not settle into one smooth, constant value. It showed fluctuations, subtle changes, little hills and valleys and what should have been almost nothing. Those changes may sound small, but they are not small in meaning. If you are trying to understand how the heliosphere is shaped, how it interacts with the galaxy, and how cosmic rays and plasma move through that frontier, density matters. It tells you how material is distributed. It tells you how waves move. It tells you where pressure builds. It tells you whether the sun's bubble is stable, squashed, stretched, or still leaking influence into nearby interstellar space. And then there was another clue: the magnetic field. Voyager's magnetometer has been reading the magnetic environment around the spacecraft for years. At one point, scientists noticed something odd. The magnetic field strength around Voyager increased and stayed elevated much longer than a simple passing disturbance would suggest. At the same time, plasma density measurements also rose. That combination opened up a fascinating possibility. Maybe Voyager had moved into a different patch of interstellar material. Maybe it had entered a region with stronger magnetic properties. Maybe the boundary zone around our solar system is not one clean surface, but a more complex area with folds, compressed regions, and pockets of different conditions. Think of a coastline. From far away on a globe, a coastline looks like a smooth line, but when you zoom in, it becomes irregular. The line was never truly simple. It only looked simple because you were too far away to see the texture. Voyager is doing that zoom-in work for the edge of the solar system, and real places are always messier than diagrams. Before Voyager, we had to infer the heliosphere's edge from indirect observations and distant instruments. Now we have a probe physically out there, taking direct readings in the region itself. That changes everything. It also changes how we think about safety in cosmic terms. The heliosphere acts like a shield. It does not block everything, but it helps protect the solar system from some of the charged particles and cosmic radiation coming from deeper space. Understanding its shape is not just an abstract puzzle. It matters for how we model radiation risks, how we understand the space environment around our planetary neighborhood, and how we plan future missions that may one day go far beyond Pluto and beyond the heliosphere on purpose. In other words, Voyager is not just telling us where it is. It is helping us understand what home actually means on a galactic scale. And the truth may be that home has edges that flex. That idea becomes even more emotional when you remember the age of the spacecraft. Voyager 1 was launched in the era of disco, landline phones, and typewritten reports. The world that built it no longer exists. Entire industries have risen and fallen. Children born after its launch have become grandparents. And still, this spacecraft keeps going, drifting farther into the dark with hardware that seems absurdly old by today's standards. But old does not mean weak. In Voyager's case, old means proven. It means designed strong enough to survive nearly half a century in a place no repair crew can ever reach. It means engineering so careful that a signal weaker than a household bulb can still be heard across billions of miles by giant antennas on Earth. It means patience so extreme that when something breaks, engineers cannot rush. They have to think, test, predict, and then wait almost a day just to see the first sign that the spacecraft heard them. That patience was tested hard. When Voyager 1 ran into a major communications problem, in late 2023, the spacecraft started sending back unreadable data. Not silence, not total loss, something more maddening, gibberish. Engineers could tell Voyager was still alive, but the information coming back no longer made sense. Imagine a patient in the most remote place imaginable, still breathing, still answering, but speaking in a language no one can understand. That was the problem. And remember where the patient was. Not on the moon. Not at Mars. Over 15 billion miles away. One command took more than 22 hours to arrive. One reply took more than 22 hours to return. So every troubleshooting step stretched into days. The team had to identify the damaged part of the flight data system, figure out how to work around corrupted code, move software into new parts of memory, and carefully rebuild the path by which Voyager packages and sends information home. It worked. After months of silence in practical terms, engineers got readable engineering data. Back again. Then they pushed farther. Bit by bit, they restored the spacecraft's ability to return usable science data. That recovery was not just a technical win. It was a reminder of something beautiful about exploration. The mission is never only the machine, it is also the people who refuse to give up on the machine. A spacecraft launched in 1977 is flying through interstellar space. It has crossed the edge of the sun's bubble. It is detecting a faint plasma hum in the gas between stars. It is helping reveal that the boundary around our solar system is irregular, influenced, and complex rather than smooth and final. On Earth, teams still listen to it through a global network of huge dish antennas pulling meaning out of a whisper. Voyager is not just reporting on distant space, it is reporting on a region no other active spacecraft can replace. When these last instruments finally go dark, that window closes. Not forever maybe, but for a very long time. We do not have another interstellar probe racing behind it. We do not have a backup already built and waiting. What Voyager is measuring now is coming from one lonely craft, in one narrow path, during one brief slice of history. That makes every bit of data feel precious. A lot of space headlines promise sudden revelations. Aliens, hidden planets, cosmic disasters. This story is different. It is slower, quieter, and more honest than that. Voyager did not reveal a giant hole ripped through reality. It revealed something better, that the true edge of our solar system is not simple. It has texture, it has tension, it has structure. It may have compressed regions, changing densities, and magnetic distortions that make the whole boundary feel less like a shell and more like a living frontier. And that is how science often works when it is at its best. Not with one dramatic shout, but with a long series of careful whispers that slowly change the picture in your mind until you realize the universe is not what you thought it was. If you have ever wondered what space is really like once you get beyond the planets, Voyager's answer is both haunting and beautiful. It is not empty silence. It is not a clean escape from the sun. It is a place where old forces and new forces overlap, where the imprint of our star fades slowly, not instantly, where plasma hums, where density rises and falls, where magnetic fields bend, where outside turns out to be more complicated than anyone hoped and more fascinating than anyone feared. That is why the mission still matters right now, not just as history, but as active discovery, and the next chapter may be just as tense as anything that came before. NASA has already been forced to shut down more instruments to save power. The spacecraft loses about 4 watts each year. That may not sound like much until you remember how thin the power margins have become. When you are surviving on the edge, 4 watts can be the difference between one more year of science and one less voice speaking from interstellar space. In April 2026, NASA shut off the low-energy charged particles instrument on Voyager 1 to buy more time. Engineers said that move could give the mission about a year of breathing room. Not decades, a year. That is both hopeful and brutal. Hopeful, because even now the mission can still be extended. Brutal, because every extension has a cost. Every extra month means something else may have to go quiet. The surviving instruments are not just tools anymore. They are the last candles left burning. That is why NASA has been preparing a risky plan nicknamed the Big Bang. The name sounds dramatic, but the idea is practical. Replace or reconfigure groups of powered devices with lower power alternatives so the spacecraft can stay warm enough and keep returning science. Voyager 2 is supposed to test the approach first because it has a little more power to spare and is closer to Earth. If the fix works there, a version of it could be used on Voyager 1. Imagine doing that kind of surgery on a spacecraft nearly a light day away. No mechanic can touch it. No astronaut can visit it. No second chance comes quickly. Every instruction has to cross the void at light speed, and even then it arrives almost a full day late. This is not just engineering. It is patience turned into survival. Second checkpoint, and a different kind of favor. If you want more stories where science feels this human and this huge, subscribe, tap, like, and share this video with the one person who always says, "Space is cool, but never realized it could feel this personal." The deeper you look at Voyager, the more it stops being just a spacecraft and starts feeling like a message about us. Think about what humanity chose to do. We built a small machine, we put music and greetings from Earth on a golden record, we packed it with instruments, then we launched it, not knowing whether it would last 4 years, let alone 5 decades. That act alone says something extraordinary about our species. We are fragile, short-lived, often divided, and stuck on one small world. Yet again and again, we build things that carry our curiosity farther than our bodies can go. And unlike a lot of symbols, it still works. It still tells the truth, even when the truth is inconvenient. It still sends back measurements that force scientists to update old ideas. It still proves that the universe is not obligated to match our first guesses. In a strange way, that may be the most important lesson in the entire story. The solar system did not end in a clean line because neat lines are usually for textbooks, not for nature. Reality has gradients, boundaries blur, systems overlap. The closer you look, the more every border becomes a zone. Instead of asking, did Voyager find a crack? The better question becomes, what is the boundary of a solar system really like when you finally measure it from the inside? And the answer, so far, seems to be this. It is uneven. It is active. It is shaped by flows and fields. It carries signs of both the sun and the larger galaxy. It may include compressed regions and distinct patches of interstellar material. It is not a perfect barrier. It is a frontier with memory. Voyager also forces us to confront scale in a way almost nothing else can. We throw around huge numbers until they stop meaning anything. Billions of miles. 17 kilometers per second. A day for light to travel. But the emotional weight returns when you make it personal. Somewhere, right now, engineers are sending commands to a piece of human hardware, knowing they will not learn the result until tomorrow. Somewhere right now, giant dishes on Earth are listening for a signal so faint, it would disappear in ordinary life without a trace. Somewhere right now, a craft built with 1970s technology is reading the plasma and magnetism of interstellar space better than anything newer can, simply because it is there. Sometimes, the only way to know what a frontier is really like is to send something across it and listen. Voyager crossed, and it listened. What it heard was not dramatic in the Hollywood sense. It was not a voice. It was not a signal from aliens. It was subtler than that. A thin monotone hum, a persistent plasma emission, a clue that the space between stars has a texture we can track, a clue that our solar system's border is less like a fortress wall and more like a pressured skin pressed against a wider ocean. If the heliosphere were a hard shell, then the solar system would feel self-contained, but if its edge is more like a shifting seam, then home is not isolated. It is in constant contact with the galaxy around it. The frontier is active. The outside world is leaning back against us. There's exchange, pressure, influence, change. In that sense, Voyager has not just told us something about deep space, it has told us something about home itself. This is why that steady hum is so haunting. Not because it sounds spooky, but because it sounds ordinary, quiet, constant, almost humble. The kind of sound you could ignore if you did not understand what it meant. And maybe that is the perfect symbol for this mission. Voyager's greatest discoveries do not arrive with explosions. They arrive as patience rewarded, as subtle signals finally understood, as weak tones that slowly become maps. Science often looks like that when you strip away the headlines. Not thunder, gentle rain. But gentle rain can reshape a landscape if it falls long enough. Voyager has been out there long enough to reshape one of the most important maps we have, the map of where our sun ends and interstellar space begins, not by drawing a sharper line, but by showing that the line was never sharp to begin with. And the story is still unfinished. The magnetic field could keep changing as Voyager moves farther away. The density patterns could reveal even more about turbulence in the local interstellar medium. The spacecraft could pass through new regions with different plasma properties. The Big Bang power-saving plan could buy more years, or the mission could begin to fade sooner than anyone wants. We are still inside the experiment. We do not have the final page yet. That means every update matters. Every faint bit of science data matters. Every successful command matters. Every extra month matters. Every decision about what to power off, what to preserve, and what risk to take matters. Because once Voyager can no longer speak, the silence will be real. And it may last a generation before another mission reaches comparable ground. So when you hear people say that NASA confirmed Voyager found a crack in the solar system, Remember what the best version of that claim actually means. It means Voyager helped prove that the edge of our solar system is not simple. It means the heliosphere is not a perfect bubble with a clean, frozen border. It means the boundary is shaped by outside pressure and internal force. It means the space between stars is structured, not blank. It means our cosmic neighborhood has a coastline, not a ruler straight edge. And it means a spacecraft older than the internet is still the only direct explorer we have out there, turning mystery into measurement one whisper at a time. And maybe that is why Voyager 1 grips people so deeply. It is not just far away. It represents the human habit of sending questions into darkness and waiting for reality to answer. It represents faith, not in fantasy, but in evidence. Third and final pause, and this one is from the heart. If Voyager's story gives you that mix of wonder and humility that only space can create, subscribe, hit like, and share this video so more people can discover that the quietest missions sometimes reveal the biggest truths. Now imagine the scene one last time. Beyond the planets, beyond Pluto, beyond the official edge of the sun's bubble, there's a small craft with fading power and aging circuits still drifting forward. No applause out there. No rescue. No backup. Just a machine carrying human curiosity deeper into the interstellar dark. And still it listens. It listens to plasma waves moving through the thin gas between stars. It listens to the magnetic fabric of a region no human has ever visited. It listens at the shifting seam between our sun's reach and the larger galaxy beyond. And across nearly a full light day, it tells us that the universe at the edge of home is not simple, not silent, and not finished revealing itself. Voyager 1 is not racing toward a destination it can reach. It is not trying to land. It is not returning. Its mission, in the deepest sense, is to continue, to keep moving, to keep measuring, to keep sending back truth until it no longer can. There is something almost human in that. Not because the spacecraft is alive, but because persistence itself feels alive. The will to continue, the refusal to go quiet before the work is done. Because somewhere far beyond every world we have ever stood on, one small artifact of Earth is still doing its job. Still expanding the map, still correcting our assumptions, still showing that the line between home and the unknown is not a line at all, but a restless border full of signals, distortions, and hidden structure. A seam? Ugh, definitely. A warning that the universe is more complicated than our diagrams? Absolutely. But above all, Voyager 1 is proof that exploration does not end when the easy answers do. That is when real exploration begins. One day, the last instrument will turn off. The final carrier signal will fade. The dishes on Earth will listen and hear nothing back. Voyager will continue in silence, carrying the golden record deeper, into the galaxy long after our generation is gone. But even then, its mission will not feel like a failure or a loss. It will feel like a sentence completed with perfect grace. It will have outlived expectations, out-traveled imagination, and changed our understanding of where the solar system ends. So the next time someone says, Voyager 1 found a crack in our solar system, do not picture a broken windshield floating in space. Picture something far more beautiful. Picture the edge of the sun's domain as a living frontier. Picture a boundary that bends, thickens, ripples, and remembers. Picture a spacecraft alone in the dark, hearing the faint hum of interstellar plasma and turning that whisper into knowledge for an entire species. And then ask yourself one last question. If this is what we can learn from one aging machine at the edge of home, what will we discover when we finally dare to send the next one even farther?